Applying properties of similar triangles. Our objectives are to use properties of similar triangles to find segment lengths, as well as apply proportionality in triangle angle bisector theorems. Who uses this? Architects use similarity and proportionality to give paintings an illusion of depth. Let's look at a theorem, the triangle proportionality theorem. If a line parallel to a side of a triangle intersects the other two sides, then it divided those sides proportionally. Meaning, we take AE and EB and divide them, it will be the same as if you were to take AF and divide that by FC. Let's look at an example. Okay, well, since CB and YX are parallel, we know that, hold on, let me get my pen, that way I can write, AX divided by XB needs to be the same as AY divided by YC. So now we can just substitute the pieces in that we know. Like AX is 9, XB is 4, AY is 10, and we don't know what YC is. So that's our unknown. So then we can cross multiply. So 4 times 10 is 40, and then we have simply 9x. And then to solve, we would divide both sides by 9. So you would have 49 equals x, or you can write this as 4 and 4/9. Try this next one on your own. Now that you've had a moment to try this next one on your own, let's try it together. So if we take 5 and put that over 2, it should equal our unknown over 3. So cross multiply, we have 5 times 3, which is 15, and then we have 2 times x, which is simply 2x. Divide both sides of our equation by 2, because we want to get x by itself, and we end up with 7.5. Let's look at another theorem. The converse of the triangle proportionality theorem. With this, you're just going to take what we were just doing and do it backwards. So if your ratio AE over EB equals AF over FC, then you know that your two lines are parallel. So EF and segment BC are parallel. Let's look at an example. Verify segments are parallel. So we're going to verify that MN is in fact parallel to KL. To do so, we need to make sure that they're actually proportional. So we have 42 over 21 equals 30 over 15. Well, if we look at the two of them, we end up with 2 if we simplify this first one. And if we simplify the second one, we end up with 2 as well. So since they are both 2, we know that MN is in fact parallel to KL. Try this next one on your own. Now that you've had a moment to try this next one on your own, let's try it together. Okay, so they gave us that AC equals 36. So from A to C is 36 centimeters. And then they gave us from B to C is 27 centimeters. Well, we want to figure out what AD is, and to do that we take our 36 and subtract our 20 to get 16 centimeters. We also want to figure out what BE is, so we're going to take our 27 and subtract 15, which will give us 12 centimeters. Well, now we can set up a proportion now that we have our needed information. So we can set it up as 15 over 20 equals 12 over 16. And if we were to reduce 15/20ths, we'd get 3/4. Likewise, when we reduce 12/16, we'd also get 3/4. Therefore, DE is in fact parallel to AB. Let's look at a corollary. The two transversal proportionality. If three or more parallel lines intersect two transversals, then they divide the transversals proportionally. So if we look at our diagram here, AC divided by CE is going to equal BD divided by DF. Let's look at our application. An artist used perspective to draw guidelines to help her sketch a row of parallel trees. She can then check the drawing by measuring the distances between the trees. So in this case, what is LN? Well, since they're all parallel, we can state that KL over LN must be equal to AB over BD. We also know that BD equals BC plus CD, which is BD equals 1.4 plus 2.2, which is 3.6 centimeters. So this is one of the numbers that we kind of need for this. Alright, so KL, we know that that one is 2.6. We're trying to find LN, so we don't know what that is. We know that AB is 2.4, and we just figured out that from B to D is going to be 3.6. Now we can simply cross multiply. So we'll have our 2.4 times ln equals our 2.6 times 3.6. And when we simplify this, we have ln equals 3.9 centimeters. Let's look at another theorem. The triangle angle bisector theorem. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Alright, so let's look at this a little closer. If we look at BD and divide that by DC, it's going to be equivalent to if you were to take AB and divide it by AC. Let's look at an example. We want to find RV and VT. So we want to find RV and VT. So to do so, we might want to start by setting up a proportion. So we have RV over VT equals SR over ST. Now we can substitute. We have x plus 2, which is our RV, and then our VT would be 2x plus 1, and that needs to equal our 10 over 14. Now let's cross multiply. So we have 14 times x plus 2 equals 10 times 2x plus 1. So let's distribute. So we have 14x plus 28 equals 20x plus 10. And now let's start getting x by itself. So let's move x all over to the same side of the equation, and then we're going to subtract 10. So we're going to subtract 14x from both sides, and we're going to subtract 10 from both sides. And when we do so, we end up with 18 equals 6x. And now we can simply divide by 6 on both sides and get that x equals 3. We are not done yet. It wanted to know what the distance is between RV and VT. So let's substitute that in. So for RV, we're going to have 3 plus 2, which is 5. And then for VT, we're going to have 2 times 3 plus 1, which is 7. And that concludes our lesson on applying properties of similar triangles.